Subject name Operating Systems, second year 4th semester, Unit 3, Deadlock Prevention. Let us see what is deadlocks. A process requires resources. If the resources are not available at the time, the process enters a waiting state. Sometimes waiting process is never again able to change state because the resources it has requested are held by other waiting process. This situation is called a deadlock. So it cannot waiting. Deadlock characterization. We will see in what situation deadlock will occur. That is, a deadlock situation can arise if the following four conditions hold simultaneously in the system. First one is a mutual exclusion, second hold and wait, third no preemption, fourth one circular wait. The first one is a mutual exclusion. Only one process at a time can use a resource. The another process will be requesting. The requesting process must be delayed until the resource has been released. The second one is hold and wait. Suppose a process must be holding at least one resource and waiting to acquire additional resources, that is currently being held by other resources. No preemption. Resources cannot be preempted, that is, a resource can be released only voluntarily by the process holding it after the process has completed its task. The fourth one, the final state, is the circular wait. So it will be waiting under the circular process. Suppose the set of process from P0 to Pn is available. Each and everyone will be waiting on the process one by one. P0 is waiting for the resources held by P1 and P1 is waiting for the resource by P2 and so on up to Pn minus 1 is waiting for a resource held by Pn and Pn is waiting for the resource held by P0. So in this format, that is circularly it will be waiting. Let us see how to prevent deadlock. By ensuring that at least one of the necessary conditions cannot hold, that is, we can prevent the occurrence of the deadlock. That is below states: mutual exclusion, hold and wait, no preemption, circular wait. Mutual exclusion. The mutual exclusion condition must be hold, that is, at least one resources must be non-shareable. Suppose the shareable resources in contrast do not require mutually exclusive access and thus cannot be involved in a deadlock. Let us see one example for mutual exclusion. So read-only files are the good example for shareable resources. Suppose at a time so many processors are trying to access the same read-only file, it is granted simultaneous access to the file because the process never needs to wait for the shareable resources. In the deadlock prevention, hold and wait will never occur because whenever a process requires a resource, it cannot hold any other resource. The next deadlock prevention is a no preemption. This type of resources have already been allocated. To ensure that the condition does not hold, we can use the following protocol. Suppose any process is holding some resources and another process is requesting the same resource, it cannot be immediately allocated. Then all resources in the process is currently holding or preempted. Circular wait. This condition never holds. It is impose a total ordering of all resources and to require that each process requests resources in an increasing order, that is R1, R2 up to Rn. Circular wait state. We assign to each resource type a unique integer number which will be allows two resources and to determine whether one precedes another in our ordering. Formally, we define a one-to-one function, that is f which assigns r which is one-to-one, that is r implies n, where n is a set of natural numbers. Thank you.